Welcome to This Explainer. Today, we're going to dive headfirst into some of the most mind-bending mysteries of the cosmos. Drawing on some really fascinating insights from BBC's Sky at Night magazine, we're taking a journey that moves from our own solar system all the way out to the absolute edge of reality itself. We're going to explore 9 cosmic quandaries that have literally kept the world's top cosmologists scratching their heads, and, well, we'll try to make sense of the vast unknown together.
But, before we get into the nitty-gritty specifics, we really need to ask the overarching question. What is the biggest mystery of all? Well, after centuries of building bigger telescopes and running these massive, complex computer simulations, astronomers have basically realized that the ultimate mystery is the universe itself. The sheer scale and complexity of the whole thing completely defies our everyday logic. So rather than just firing off a random list of facts, we're going to zoom out. We'll explore this through 5 thematic chapters, starting with a mystery that hits very, very close to home, and then we'll expand our view outward until we're looking at the ultimate fate of everything.
Chapter 1. Are we truly alone? Searching for life and unique worlds. Let's kick things off right in our immediate neighborhood with a 2-part question. Is our solar system unique, and is there life beyond Earth? Okay, let's dive into this. For a really long time, we didn't even know for sure if other stars had planets. Today, we absolutely know they do, but we actually haven't found any exact copies of our solar system yet, largely just due to the limits of our current tech. Plus, out there, we see some truly wild things, like hot Jupiters, these massive gas giants orbiting dangerously close to their stars, basically knocking smaller, Earth-like planets completely out of their orbits in this crazy game of cosmic billiards. But what about life in our own backyard? Astrobiologists think 3 specific local spots hold our best chances for finding microbial life. First, we have Mars, which shows a ton of evidence of past warmth and running water. Then there's Europa, one of Jupiter's moons, which is hiding a vast, liquid subsurface ocean. And finally, Enceladus, Saturn's moon. This one has a warm interior and literally shoots icy particles and organic compounds right out into space. Finding even a single fossilized microbe in just one of these places would be a massive game changer, because it would immediately tell us that the origin of life is actually incredibly common. But if it is common, we smash right into a massive wall. The observable universe has 100 billion galaxies, each with tens of billions of stars. Mathematically speaking, even if life forms on a tiny microscopic fraction of planets, there should be billions of life-bearing worlds out there. And that brings us straight into the incredibly chilling Fermi paradox. The famous Italian physicist Enrico Fermi basically looked up at the sky and asked, where are they, right? I mean, if alien civilizations are so abundant, they should have found and visited us by now. Yet, the cosmos is entirely, completely silent. It's an unproven hypothesis either way, but it definitely leaves us wondering, does evolutionary biology naturally lead to technological intelligence, or are we just some strange, incredibly lonely anomaly?
Chapter 2. The Invisible Cosmic Iceberg, Unveiling the Hidden Universe. Zooming out from local planets to entire galaxies, we hit our second major wall of the unknown. How do these galaxies actually form, and what is the universe actually made of?
So our current understanding, which is called the concordance model of cosmology, brilliantly illustrates just how blind we are to our own reality. Everything we can see, whether with our own eyes or our most powerful telescopes, every star, every gas cloud, every planet, you, me, the device you're listening on, makes up a tiny 4% sliver of ordinary particles. In fact, actual visible matter is just about 1% of the grand total. The rest of the universe, it's completely invisible to us. Let's break down those bigger slices to really grasp the vastness of what we simply cannot see. Let's look at that 26% slice. You can think of dark matter as the massive, hidden bottom of a cosmic iceberg. Now, we know it's there because we can clearly see its gravitational influence. It pulls on visible galaxies, it dictates how fast they rotate, it even acts like a massive magnifying glass, bending starlight from objects behind it. But scientists know for a fact it can't just be dim stars or regular atoms. If it were, then nuclear reactions way back during the Big Bang would have produced a completely different mix of elements than what we actually observe today. So dark matter is made of totally mysterious, non-baryonic particles. Basically, that just means it's not made up of normal protons and neutrons like you and me. And to this day, we still cannot directly detect it. But hold on, because it gets even weirder with dark energy, that massive 70% chunk. If dark matter is the hidden iceberg, dark energy is the vast, pitch-black ocean this iceberg is floating in. Back in 1998, astronomers discovered something that seemed practically impossible. The universe isn't just expanding, its expansion is actively speeding up. Think about it. Gravity should be pulling everything back together, slowing the whole expansion down. But instead, this mysterious repulsive force of empty space, which we call dark energy, is actively pushing galaxies apart faster and faster.
Chapter 3: Decoding the Big Bang, the violent origins of everything. Tracing this accelerating expansion backwards in time naturally brings us to our next huge question. What caused the violent origins of everything? And did a rapid expansion called inflation actually happen?
So, when cosmologists look out into the deep universe, they run into a big problem. The temperature and the structure of the cosmos are just incredibly uniform everywhere. But remote parts of the universe were never in touch with each other. So, how could they be so perfectly matched? To explain this, scientists theorize an event called inflation. This was a tiny infinitesimal fraction of a second right at the very start, where space blew up exponentially. We're talking going from the size of a subatomic speck to the size of a grapefruit in an absolute flash. This essentially ironed out any irregularities before settling into a much slower expansion. Now, it perfectly explains our observations, but the profound mystery is still there. We have very little direct observable evidence that it actually happened. Tracing the violent origins of the cosmos takes us from 0 seconds all the way to our present 13.8 billion-year-old observable universe, but it leaves us with an incredibly heavy philosophical cliffhanger. If you want to know what caused the Big Bang, you have to assume there was a prior event, right? But if the Big Bang created space and time itself, the word prior literally has no meaning. Actually, some physicists suggest our universe was spawned by empty four-dimensional spacetime colliding with another universe. But the really crucial takeaway here is, even if that's true, if something caused the Big Bang, what caused the cause? It gives you a bit of intellectual vertigo just thinking about it.
Chapter 4: Testing the Cosmic Rules. Was Einstein wrong? To even attempt to understand things like the Big Bang and dark matter, we have to rely entirely on the fundamental laws of physics.
Now, we know Isaac Newton wasn't wrong exactly. Newton's theory of gravity is unbelievably accurate, literally accurate enough to fly spacecraft perfectly to the moon. But it does break down under extreme conditions, and that is exactly where Einstein's general relativity steps in, perfectly describing the warping of space around black holes and the bending of starlight. Einstein has passed basically every test we've thrown at him with flying colors, but anomalies do exist. For instance, the unexplained deceleration of the Pioneer 10 and 11 spacecraft. They slowed down a bit more than expected as they left the solar system. It's a tiny detail, but it hints that maybe, just like Newton, Einstein's brilliant theories might simply be incomplete, just waiting for a new generation to discover an even deeper truth.
Chapter 5: Destiny and the Multiverse, the End of All Things and Alternate Realities. For this final chapter, let's push our minds to the absolute limits. Could the universe have been completely different? And how is this all going to end?
Physicists can measure the mass of a proton or the exact strength of gravity, but nobody knows why those values are what they are. What we do know for sure is that if you slightly tweak the mass of a particle or if you dial up the strength of a nuclear force just a tiny bit, the entire universe becomes a sterile void, completely devoid of stars, planets, and life. It seems perfectly fine-tuned for us. And this leads to a massive mystery. Are we just incredibly, unbelievably lucky? Well, some cosmologists suggest we actually live in a multiverse. The idea is, if there are zillions of universes floating out there, every possible combination of physical laws exists somewhere. We, naturally, just find ourselves in the one that allows us to exist. We didn't get lucky, we basically just bought every single lottery ticket. But what about the end of the line? As for our destiny, the cosmic baby boom is officially over. The stellar birth rate is actually already past its peak right now. Fast forward hundreds of billions of years, and star formation dwindles down to nothing. But thanks to that mysterious dark energy we talked about earlier, the universe will probably never collapse back in on itself. Instead, galaxies will just endlessly recede from one another. Eventually, they'll completely disappear beyond each other's cosmic horizons, leaving a dark, lonely, and freezing void. Or, and this is wild, if dark energy actually gets stronger with time, it could lead to what's called a big rip, where atoms and space itself are literally physically torn asunder. Which leaves us with a final, lingering thought to wrap up on. As we continue to build these massive telescopes and run deeper, more powerful simulations, we inevitably realize that every single answered question just reveals a deeper, more profound layer of the unknown. We've gone from just wondering about simple comets in our sky to actively questioning the fundamental fabric of reality itself. So I'll leave you with this.
When those final stars do burn out and the universe fades to black, what unimaginable, mind-bending riddles we'll be asking in the dark? Thank you so much for exploring the cosmos with me on this explainer.